Hey guys, Mr. Richards here. Let's get going over this short little homework. Only 2 questions long. Although these questions do have A, B, C, D, E parts, you could say 10 questions long. Let's hop to it. So, says Mr. Richards went to fill his empty 24-ounce water bottle at the school water fountain. Counting his head, he noticed it took 13 seconds to fill it up completely. By the way, this is actually accurate. This is how long it took me to fill my water bottle the other day. All right, explain why the situation can be reasonably described as linear. Anytime you're looking for something that is a linear situation, you want to be looking for a constant rate of change. Constant rate of change. That is what you are looking for. In this particular question, there is a constant rate of change, specifically the water going into the cup, or the water going into the bottle, the water coming out of the fountain, whatever it is. Coming out of the fountain is a constant rate of change. You turn the water on, it comes out at a constant rate until it stops. Someone could argue that it's not exactly constant. It's a little bit more for a second, a little bit less for a second, but it's basically constant for all intents and purposes. All right, find that rate of change. Whenever you're asked to find this rate of change, this basically always means slope. Slope is that value m that we have. This is our y2 minus y1 over x2 minus x1. And this pen's giving me trouble. I'm switching pens. Do a different color. We'll go purple. All right, so yeah, it's like fading, in and out. It's like not looking pretty on the screen, so I'm not happy with it. We're gonna have to make that brighter. That's a little bit better. Anyways, you have the constant rate of change, water going out of the fountain, and we are now finding that rate of change. That is always the slope, y2 minus y1 or x2 minus x1, of the amount of water in Mr. Richards' bottle as a function of the seconds since he started filling it up. So in the previous assignment, I kind of had you guys write in the board when it says with respect to. Whenever you see those words with respect to, that always meant that was your input or your x values. This is another setup that means you use those x values. So whenever you see the words as a function of this part right here, whatever comes next is going to be your input. Whatever's next, which is right here, this is your input or your x's. Which means that our x1 is when Mr. Richards began started counting in his head for this 13 seconds. So we start off at a time of 0. And for the second one, 13 seconds later. Our y1 is also 0 because it's how much water was in our cup at the start of the problem. And because it was an empty 24-ounce water bottle and he filled it all the way up, that's our y2. That's 24 ounces. So our slope here is going to be m is equal to 24 minus 0 over 13 minus 0, which we can just leave as 24 over 13. Or you can use a calculator if you decide not to leave it as a fraction, which is completely reasonable. If you decide not to leave it as a fraction, it is approximately, I've got 1.846. That's what I'll do. I'm going to leave it as 24 over 13 for this question because fractions are kind of easier to deal with. There's no decimals in the problem. So I'm going to leave it as this guy. I would also like to say that there is the rate here. We would say 24 over 13 ounces per second if we wanted to add those units because it says ounces and seconds for our time. All right, so write a linear function, w of t, that gives the amount of water in Mr. Water as a function. The seconds you start filling it up, so we have w of t equals, and we want to be using this equation, f of x is our m, x minus x1 plus y1. That's what we want to be using. So our slope there is 24 over 13 multiplied by t, because that's our kind of our x values, minus 0 plus 0, because there's our x1 and our y1, which of course these are both 0, so they almost don't even need to be written. Much better to just write it like this. And again, if you used 1.8 or 1.846, full credit, there's our equation. How much water is in the water bottle after 5 seconds? Well, this is asking us to replace the time with a 5. So that's like W of 5 is going to be equal to 24 over 13 multiplied by 5. which if we use the fraction version of the answer, it'll be 120 over 13. But really, this is like in this problem, when you're doing slope and doing math, more exact answers are more appropriate. But when you're doing like how much water, this is like a physics or a chemistry kind of answer, or a reality kind of thing. You don't tell somebody I have 120 over 13 ounces of water in my cup. You would much rather say the approximation of that guy, which is about 9.231 ounces, or even just rounding it to 9 ounces would probably be the most reasonable real life situation. So either of those is good. If Miss Richards bought a brand new 32-ounce water bottle, how long would it take for him to fill it all the way up? So this is asking us, it says how long. It wants to solve, this is saying t equals what? So if you're solving for a t, we know that 24 over 13t, that part of the equation up there, is going to be solved for, and we are specifically asking how long would it take to fill up a 32-ounce water bottle there. So you're making the w of t equal to a 32. Solving this equation, if you have the decimal, you just divide both sides, or if you have the fraction version, multiply both sides by 13 over 24, or just divide by 24 over 13. But whatever it is, you got to plug it into your calculator. If you decide to get the exact answer there, it would be 13 by 24. This is going to be equal to 52 over 3 seconds. Sorry about that. 52 over 3 seconds, which is, it does have an approximate answer of 17.333 seconds. So take a whole extra 4 seconds if you increase the size of the water bottle there. All right, well, there's all of problem number 1. Hopefully it didn't go too quickly there. Let's move on to the second problem on the next page here. All right, while bored during a bus ride, Jimmy noticed the bus passed mile marker 33. Exactly 30 minutes later, he noticed the bus passed mile marker 69. Nice. Explain why the situation can be reasonably described as linear, and that is because the bus moves at a constant speed. The bus moves at a constant speed. If you wanted to simply use the same exact language from the previous page, you could say constant rate of change, which is the bus moving. So it says in miles per hour, how fast is the bus going? So how fast is the bus going? That is your rate of change. It's it's a movement. All movement's gonna be a rate of change there. So you got to figure out how quickly you're going. If you noticed, you have your in miles per hour, which means miles over hours. It means your miles are going to be your y and your hours are going to be your x's. Another way of remembering is if it doesn't tell you in the question your time values, then sorry, if it doesn't tell you in the question what values are your x's, time are going to be your x's. So we have x1 equals x2 equals, we are starting off at 0 minutes because we have no other minutes available, and at x2 is 30 minutes later, but it says in miles per hour, so we have to use this 1/2 right here, which we could just write as 0.5. Probably gonna be better for this type of question. y1 is our first mile marker, 33 mile marker, and the second mile marker there, 69, and m equals, we have 69 minus 33 over, and again, I think decimals are more appropriate on this question, minus 0 equals, and if you plug that into a calculator, well, from alpha, whatever you decide to use, what do we get? Looks like this is exactly 7, oh duh, because dividing by, duh. So this is exactly 72 miles per hour. Bus is cruising. Probably should not be moving that fast, Mr. Bus guy, but who am I to judge? 72 miles per hour. Here we go. Create a linear function M&T that has input hours, since Jimmy noticed the bus passing mile marker 33, and an output of the current mile marker. So same exact idea. So we have m of t equals our slope, which is 72, multiplied by our input of time minus, in this case, 0, plus 33, which we will distribute that. But 72 times 0 is 0, so we just have plus 33. And there is our beautiful little equation. Here we go. Which mile marker will the bus be at 2 hours and 15 minutes later? So this is, again, requiring us to make sure that we plug everything in for time. We want time to be equal to 2.25. So let's figure out where I got that 2.5. So 15 minutes right there. 15 minutes is a quarter of an hour. Quarter hour. And that's where I got the 0.25. If you wanted to be a little bit fancier with it, you could do your dimensional analysis on it, just like in chemistry. And you would do like 15 minutes multiplied by 1 hour divided by 60 minutes. And if you did that, the minutes will cancel out and you'll get 15 over 60, which is 0.25. That's the fancier version of it. Like visually, I mean, not really too many other options there. I kind of have to do some version of conversion, some version of converting to get to answer. Either way, you get time is 2.25, which means we have m of 2.25, which is going to be 72 multiplied by 2.25 plus 33. 72 times 2.25 plus 33. And if you do that, that will be 195 is the mile marker. There we go. Assuming there's a bus doesn't stop, how long will it take for the bus to reach mile marker 420? So if you want to do that, that means that now we're saw again how long. This is asking t equals what, which means we have to solve our equation of 72t plus 33, and we are setting that equal to 420. So kind of a basic subtraction situation. Subtract 33 on both sides there. And that's going to give you 72 with the t. Subtracting 33 there, what's that going to be? 387. Yeah. And then divide both sides by 72. It's going to be 5.5 or something like that. So divide by 72. 387 divided by 72. Turns out that is exactly equal to 43 over 8, which is approximately, or actually this is exactly equal to 5 points. I think it's 375, right? Yeah. 5 hours. There you go. All done. Have a wonderful rest of your day and a wonderful little 5-day or 4-day weekend, right? Thursday, Friday, Saturday, Sunday, 4-day weekend. Have a good one, guys, and peace out. See you.